So I think we're ready to look at problems on this set 2-4. Well, let's see. I don't know whether we're going to get to it by Wednesday or not. It depends on how today and Monday go. But 2-5 is not, dimensional analysis is not too difficult. If we don't have it on Wednesday, then it'll have to be the following Monday, because the people are going to be gone for.
So say again, we're having our normal quiz on Wednesday or the test on Wednesday?
Test on Wednesday, possibly.
Possibly.
If we don't have it on Wednesday, we probably won't have a quiz on Wednesday. We'll have a test on Monday. Okay.
Right.
So it's asking you which of the shapes are polyhedra. Now, the first one, A, can't be. If you remember, I called your attention, it can't have a hole in it. So this has a hole. So this is not polyhedra. B, they were talking about it has to be flat surfaces, so no flat surface. So this is not a polyhedra. C is the only one that is. Now, if you look at 4, what that is, they show you a figure, and then they show you for that particular figure, and they got 2, 2, 3, 1, 1, and 1. If you think about that thing is laying flat underneath that figure, and then it's saying how many high are the cubes. So if you lay it flat underneath that figure, the back row, the leftmost column is 2 high, and then the middle column is 2 high, and then the rightmost column is 3 high. Does that make sense? That's what that box with these numbers in it is just saying, you understand? It's as if you laid this box underneath that pile and then said, how high are the blocks in this particular region? You understand what I'm saying? Maybe not.
Of the chart, bottom row is in front of you, the first level, and behind you is the second set, so to speak.
Yeah.
Okay.
See,
yeah, I got it.
What it's doing, if you think about and I shouldn't have put this here. But anyway, this is essentially the back row, right? And you see, this is this row right here. It's like that box is laying underneath there. And it's saying that this thing right here has got 3 rows in it. 2 rows, excuse me. 2 columns high, 2 high, 3 high. And then that front one, there's just 1, right? So this is telling you what's right here, 1, 1, and 1. So if you look at A, and let's just make the box that lays underneath that. The how high is the column in the back row, leftmost column? There's 3 in it, right? There's 3 blocks high. And then the next one over, it's 3 blocks high, and the next one over, it's 3 blocks high, right? Do you see that? And then if you go into the front row, then it's 2 blocks high, 1 block high, and 3 blocks high. Does that make sense? Tell me it makes sense or don't make sense, one or the other. Okay. Vince, you got it?
I'm good.
Okay.
I'm trying to draw the picture for Sadie,
Okay.
but I'm not a very good artist.
Yeah, well, now it says, so that's A is Roman numeral 2, right? Is the answer to that one. So now B, it says make the chart. So then what you do,
This chart's gonna be 3 levels high.
it's going to be, what it's going to be is, what you should do is you should think about underneath that what you're looking at it from the bottom. This is on the base, yeah. That thing is setting. So then this is the back row, leftmost column. So what would you have? You'd have 3 blocks high, right? Then you'd have 2 blocks high. Then you'd have 5, right? Then you come forward 1 and it's 0, right? 1 and 2. Then it's 0, 1, and 1. Is that good? Is that? Now the next one, let's see whether I can draw it. I don't know which one, but it's gonna be. Now notice that it's 3, 2. I better be freehand. That first one is 3, and then when it goes down to 1 in that front row, right? And the second one goes down to 1 in the front row. So then this is going to come out. This is going to come out. So that's 3, 3, and then the next row forward is 1 and 1, right? Then the next one is 2. Nah, I don't want, that's behind there. Then back in behind here, it's got one. So it comes out here, goes back. No, I did that wrong. It's gonna come out here.
Professor, you gotta lose
No.
that block.
No, I'm doing it wrong.
This block doesn't belong here. Only one's in the first row.
That's a 2 and 2. See, it's a 3 and 1, 3 and 1, 2 and 2, and then the back row. The back row has got to be.
Oh, I'm sorry, my mistake.
Yeah,
My
dang.
mistake.
Stupid.
Pay attention.
There's got to be. It's got to come out. No, it's got to come out here. Here. And back there. It's clearing that back. There's one. Because if you lay, I'll try putting it out here to the side. If this is what's underneath it, we pulled it out. That this is a 3. See, when I pulled that out from underneath there, there was 3 on top of this. There was 3 on top of this. There's 2 on top of this, and there's 1, right? Then there's 1 on top of this, 1 on top of that, 2 on top of that, and 0. Correct? I'm not sometimes so good at drawing perspective, but you think about that numbered box as just like the rug underneath it, and you're telling how many blocks are on top of it. Okay. Number 6. Now 6 is those hexominnows. Those are those. They're five blocks, and then has to be 2 in each row. But this says no, there's 6 connected squares where 2 squares are joined along the entire side. Remember, there were 35 different hexominnows, and this says which one of those fold into a cube. So there's 11 of them. 3, 6, 5, 10, 11. So one of them. So if you fold that around, it'll fold into a cube, right?
Yes.
Then if you take another one is if you do 3 on the end. And then do 3 this way. That'll fold into a cube. And then another one is that one. And then another one. to see how that one works. And then another one is the two flappers out there, the ends. The rest of it's just center part. That's another one. Another one that's that one. Are there any of these that you don't see how they work? And the last one is this one. And that's all out of the 35.
Are those 35 listed somewhere?
Remember, we did them, I don't know, in a problem back section 2, yeah. I don't know if we listed them out or not. I don't think we did. 30. I don't think I can't imagine I listed 35 of them out. But these are the ones that meet that criteria that fold into a cube. All right, and number 8. Oh. Why the heck is that? What I did. How did I lose it? I lost the other one. I'm still recording, so. 8. What? I, well, maybe I can. How do I make that thing?
Just click right on it in the middle of it.
It's actually pulled down. There it is in the bottom.
What?
It's pulled down to the bottom of your screen.
So I have to pull this up?
You have to, you're starting to pull it up. It's in the bottom underneath all that.
Oh, I see.
Yeah. Just like scroll off the back.
Move to the right a little bit.
Yeah.
How come it comes up there and it won't go on up?
It's underneath your toolbar. He was beginning of this grievance.
Down here?
Mm-hmm.
Now what do I do?
Scroll off of like the icons. And yeah, scroll to the right off the icons and then
Give him a hand. I see it too.
yeah.
It's like the bottom.
It's just right down here at the bottom. It'll pull up.
No, okay.
There we go.
Thank you. All right. So the next one says, do the following for the given prism. Now you have to assume the segments that look like are congruent. That if they look congruent, they are congruent. If they look like they're right angles, they are right angles. And so they want you to name the bases of the eight. So if I make this thing,
Does a prism always have two bases?
yeah. Okay, and then they letter these Q, S. Then there's R. All right, the first thing is, which are the bases? Give the letters of the bases. Now, prism, if you look on 76, says two common types of polyhedra we will study are prisms and pyramids. A prism is a polynomial with two opposite faces called bases that are identical polygon regions in parallel planes. That is, the planes that do not have any common points. The other faces are called lateral faces. So which are the bases? They have to be identically shaped in parallel planes.
I don't see it.
Anyone have it?
Plus,
Oh, if you look at N, Q, T, P, what's the name of the shape that's exactly like it in a parallel plane?
I see.
The other one is
NROS.
SO.
Okay, I'm thinking top and bottom.
Yeah. See, those aren't identical. They're in parallel planes,
Right.
the top and the bottom, but they're not identical shapes. So these are the bases. So the lateral faces. So there's going to be what? Going to be 4 of them, aren't there, right? So if you go around the thing this way, right? you look at the bottom, it's a Q, R, S, T. Then if you, and then if I look at the front face there, I go T, S, O, P. Then I look at the top, I go P, O, N, M. And then I look at the back, I go the N, M, Q, R. Right? The faces are going around it like this. Front and back are the bases, and then the lateral faces are the ones that come around it. So of those faces, which ones are hidden from view?
Anything with a dotted line, huh?
Yep.
And then a Q,
Okay.
NRS, that
M,
would be a base.
N, R, Q, and then you're, I don't know what you said, but it's Q, R, S, T, right?
Mhm.
You always, wherever you start, you always go around when you're the vertices and sequence around. Name the prism by type. Give as complete a description as possible. Now, if you look at it, if you look at the example in 76, you see they have a rectangular prism, a triangular prism, a hexagonal prism. So this, what would be the shape of that, the bases? It's always the shape of the bases is what.
Trap. Can we call that a trap?
No. Is that a parallelogram? It's trapezoidal. So you're right. It's right trapezoidal prism.
Lucky guess.
That's okay. 10. Name the following prisms. Give them a complete description as possible. Assume segments that look congruent are congruent, and assume angles that look like right angles are right angles. So the first one, A.
Would that be an isosceles trap?
Um, it'll be only if those two sides. It's hard to say when it's in perspective. If it's trapezoidal, the book calls it a right trapezoidal prism.
How do they figure that?
They're assuming that it's got a right angle. So what they're doing is they're assuming that in that perspective drawing that this is a right angle. But just like in that other one, it's a right angle. But trapezoidal prism would be good enough. So B, what would you call that one?
It's got 5 sides, so it'll be pentagon of some sort.
Mm-hmm. They call it an oblique pentagonal. because, you know, none of the sides are identical. But
Okay.
a pentagonal prism, all right, 12. So there's number 12. They're saying that this is a right triangular prism.
See, I don't understand that. What do you mean right triangle? Those look like equilateral triangles to me.
But it's the perspective that would, that, you know, when it's drawn in perspective, it don't show up to be, you know, the right angle. I mean, this would be the right angle, but when you're drawing it in perspective, it doesn't show that way. I mean, that's, you got to kind of assume that that's what they're. Now, the net is that you lay that out. So if I lay this out flat, this bottom right here, if I call this A, B, I'm gonna call it different. A, B, B, C, and then go D, E, and F back here. So if I make my AB, oh boy, like that. This is A, and this is D. Now what I have to do, if it's a right, I gotta come out. I'm gonna make it a dash line. I gotta come out like that, and then out like this. So when that folds up, it folds into a right angle. Then the other part of the base has got to be, this is like laying the thing out flat. Hmm. Hmm. Now what the length here, this length right here has got to be as long as this length. Same way over here. Those, because when it folds back up, so when this thing folds along here, and it folds up into a right angle. It just folds up, and then it makes that right angle. And then what has to happen, you gotta have something down here such that this side and this side are the same. Okay. And then when you fold that up, it'll be a right triangular prism. I guess to be accurate, this should be it. This thing here is a dashed line. It's a fold line, and this is a fold line. As the green lines on the sides, they're all fold lines. So when you fold it up, but it has to be, you know, these two sides have to be equal, and those two sides have to be equal, and these two sides and these two sides have got to be the same way. I've tried taking a pizza box, Pizza Hut pizza, lay it out. Boy, that thing there, that's what this is how do you lay it out so when you cut it out, that it folds up and makes into what they want. And that's what you're actually, you ever take a pizza box and unfold it and lay it out and see what it is? That's what it's got to be stamped, and that's what a net is. How do you lay it out? And that's a practical example of a net, because when you get done with it, it's got to be this box. I bought a Pizza Hut piece, and when I got done with the box, I deliberately unfolded it, and I thought, man, that'd be to try to visualize that. Take some thinking. It says name the following pyramids and give a complete description as possible. Now, if you go back and you look at the pyramids, and on page 76, it's going to tell you pyramid is a polyhedron consisting of a polygonal region for its base, and the triangular regions has lateral sides, so it has to have triangles on the lateral sides that all meet in this apex point, and then the name of the pyramid is determined by the shape of its base. And then it says the perpendicular distance from the apex to the base of the pyramid is called the height of the pyramid. And then it says when the base of the pyramid is a regular polygon and its lateral faces are isosceles triangles, the pyramid is called a right regular pyramid. But if the lateral faces are not isosceles, the pyramid is called an oblique regular pyramid. And then you're talking slant height is what they talk about, and that's from the apex down one of the sides to the base. So that being said, then 14A, what are we going to call that? So what is the base? Okay. So that would be a right regular pentagonal pyramid. And then B is going to be called what? Oblique, right? Oblique. And what is the shape of the base? Square. 16. It says, which of the following are nets? Which of the following nets can be folded to form a square pyramid?
It's going to be
Is there any other ones?
looks like a
B, yeah, A and B, both. But C is not going to work. Okay. 18. So this is a rectangular pyramid, so
You set them up just like 16A. Or B for that matter, right? Well, no, now it's a rectangle.
yeah, that's the trick. So if you drew a net, you'd have a full line on one side, full line on the other side of the rectangle, right? And then you put a full line there and a full line there. That would be your base. But that would have to be halfway. I'm not drawing this so good. If I drew that there, this would have to be the same distance down and in the middle, right? Plans. No, those two things on each side would have to be identical. But now, on the ends, what would it have to be?
It'd have to be longer than those due to the length of the rectangle.
This side right here would have to equal in length this side over here. Right? So you'd have to have a point out here, someplace where those two sides, those two would have to be equal, these two would have to be equal. And then on the other side, you would have to have the same thing. Well, let's see. These two would have to equal, and they'd have to be all equal here, right? And then your thing going out would have to be the same shape as this one on this side here. For those two sides, this one and this one would have to be the same length. And that, so it isn't drawn in perspective, but that's the way you'd have to do it to make it a net. Okay. On 20. I guess I don't want to do that. I want to do 22. The leftmost block, then the 3 on the right, which one could possibly be? It says all faces of the cube on the left have different figures on them. Which of the 3 other cubes represent a different view of that block? I would say a possible different view of that block. Which one would it be? What? Number 2. That's the only possible one that could be. What it is you just rolled the thing over, and that figure that's on the right hand side was on the bottom, so you couldn't see it. But those other 2 would be in the right perspective. So number 2 would be the right one. Okay. We're gonna have to go some to get Jamie at Christmas. This thing.